Hello, my name is Tom Tuning. I am with the IoT Foundry team here in Raleigh, North Carolina, and today I will be talking to you about data analytics and Bluemix. Let's start by reviewing a data flow which shows how applications and analytics are built in the Internet of Things world. We start with a device, be it a sensor, a gateway, or something else. Once the device is connected, messages flow via the MQTT protocol to the IBM Internet of Things Foundation. This is the hub of all things IBM IoT. This is where you can set up and manage your connected devices so that your apps can access their live and historical data. Once the data is stored in the database, you will use a secure REST and real-time API to access it. Now that you have full access to the data coming from your devices, you can create applications within IBM Bluemix, another cloud, or your own servers to interpret the data. Today, I will be talking about analyzing data and performing predictive modeling. Many organizations across industries are looking to leverage analytics to improve operational performance. However, the word analytics brings varied descriptions. I would like to talk to you about how to use Bluemix applications and services to perform predictive analytics on a set of data. But before we jump in, let's back up and describe the different types of analytics and how they are used. Traditionally, data was collected from varying sources and placed into a dataset. This dataset was then examined using several batch processes. Knowledge gained from this analysis was then used to make operational changes to the business to improve efficiency. Although very useful, this type of analytics does not lend itself to real-time decision-making. Today, we have connected devices streaming data at near real time. Imagine a sensor reading the vibration on a pipe, or perhaps a temperature of a bearing. If these key performance indicators, or KPIs, go beyond a threshold, an alert can be triggered. This is streaming analytics. Now imagine that the information gathered from a single sensor does not tell the whole story. You need to correlate related data to come up with a meaningful conclusion. This is where traditional batch processing meets streaming analytics. We need the power of batch processing at near real-time speeds. This overlap is called micro-batch analytics. Lastly, you can use batch data to develop a model of what future data may look like based on related data. Think of how you might use weather data to predict the performance of another part of your business. You apply that model to the streaming data, and you can now predict the future at near real-time speeds. Isn't that awesome? Now that we have some definitions, let's talk about how IBM Bluemix makes analytics easy. If you log on to IBM Bluemix and under Services select the Data Analytics checkbox, you will see all the data and analytics services that are available. To help make things easier, we will first talk about the batch choices that are available. Keep in mind that some of the options are tied to the type of database which stores the information. For example, if you choose an SQL database such as DB2, you can use tools like IBM Cognos, Weka, or RapidMiner to examine the data. In general, SQL and time series databases lend themselves to batch analytics better than NoSQL. But that's not always the case. You must examine your data and make the best choice for your business. Some of the choices you can make are InfoSphere Big Insights. This is a software platform designed to help firms discover and analyze business insights hidden in large volumes of a diverse range of data. Data that is often ignored or discarded because it is too impractical or difficult to process using traditional means. Examples of such data include log records, click streams, social media data, news feeds, electric sensor inputs, and even some transactional data. If you choose -DB to store relational data, including special types of geospatial data, then you can analyze the data with SQL or advanced built-in analytics like SPSS, predictive analytics and data mining, analytics with R, and geospatial analytics. There are many choices. I have just given you some of the highlights. Now let's talk about streaming analytics. Bluemix provides several services to help you get started, such as IBM InfoSphere Streams. This is an advanced analytic platform that allows user-developed applications to quickly ingest, analyze, and correlate information as it arrives from thousands of real-time sources. The solution can handle very high data rates, up to millions of events or messages per second. A database such as Cloudant provides access to a fully managed NoSQL JSON data layer that's always on. This service is compatible with CouchDB and accessible through a simple-to-use HTTP interface for mobile and web application models. Both Cloudant or DB provides programming interfaces which allow the use of high-level programming languages such as R or Python. Apache Spark is an open-source cluster computing framework with in-memory processing which speeds analytic applications up to 100 times faster compared to technologies on the market today. The IBM IoT Real-Time Insight service allows you to understand IoT data in context and monitor the conditions of your devices and operations. IoT Real-Time Insights works with the Internet of Things Foundation to enrich and monitor data from your devices, visualize what's happening now, and respond to emerging conditions through automated actions. Okay, let's talk about the sample project we created to showcase the different types of analytics available today. We wanted to show how streaming data from a device is combined with related data. In our case, the related data was weather. Once combined, we had our data scientists analyze the data and create a predictive model. That model was then used to predict future power output of a solar panel based on weather forecasts. Let's take a look at what we built. First, we have the solar panel. It generates information about wattage and luminance. However, it does not provide a programmable environment. We needed a way to take the data and combine it with weather data and then send all of that to the IoT Foundation. Basically, we needed a gateway. A Raspberry Pi was used for this purpose. Once at the IoT Foundation, we used Node-RED to create a DB dataset so that we could do further analysis. Our goal was to predict future power output based on weather forecasts. Let's see how we did. Here's a chart which shows the predictive data compared against actual data. The blue dots represent the actual observed watts generated by the panel during April 4th. The red line models the prediction of watts during that day based on past data. So you can see that the predicted output in watts is very close to the actual numbers. This shows how accurate our model was. Our project exercised the following concepts: processing streaming data from a gateway, combining sensor data with related data, doing a batch analysis of data and creating a predictive model, and using the Internet of Things Foundation as the communication hub. Being able to accurately predict wattage based on weather forecasts is very beneficial. Here are a couple examples. From a quality assurance perspective, if a panel does not produce the predicted amount of wattage, this may indicate that something is broken and needs maintenance. The maintenance could then be planned during low wattage time. This would minimize the amount of power lost. From a usage perspective, you could schedule high utility usage during peak wattage output hours. This would reduce the amount of energy purchased from outside sources. To help you get started with the IoT platform, here are some helpful links. Thank you.